A very good morning to everyone. I am G Naresh from ECE A section. This is a PPT of control system subject. My concept video topic is about to discuss the Mason's gain formula. Let's get into the topic. In the Mason's gain formula, suppose there are n forward paths in the signal flow graph. The gain between the input and output nodes of the signal flow graph is nothing but the transfer function of the system. It can be calculated by using Mason's gain formula. So this Mason's gain formula comes into view when we use this in the signal flow graphs to determine the transfer function in a most simpler way. So the transfer function t is equals to c of s by r of s. Hence we know that the transfer function is equals to Laplace transform of the output by the Laplace transform of the input. So c of s by r of s equals to summation I is equals to 1 to n pi del I by del, where C of s is the output node and R of s is the input node. T is the transfer function or gain between R of s and C of s, and Pi is the ith forward path gain, and del is equals to 1 minus sum of individual loops plus sum of gain products of all possible non-touching loops minus sum of gain product of all possible 3 non-touching loops. And the del I is obtained from del by removing the loops which are touching the ith forward path. So in this Mason's gain formula, t is the transfer function and c of s is the output node and r of s is the input node. The transfer function is equals to output by input, that is equals to summation I is equals to 1 to n and pi into del I, where pi is the forward path gain and del I is equals to del I is obtained by from the del, and where del is equals to 1 minus sum of individual loop gains plus sum of two non-touching pairs of of the loop gains and sum of three non-touching pairs of the loops. And the definitions, when it comes to definition, the definition of path is a continuous set of branches traversed in the direction that they indicate, and a path from an input node to the output node in which no node is touched more than once is called forward path. So the path which goes from the input to output where no node is touched double time means traversing goes only through once, so that is called forward path. And a path that originates and ends on the same node in which no node is touched more than once is called a loop. The path gain is defined as the product of gains of all the branches in the path, and the loop gain is defined as the product of gains of all the branches in the loop. Let's solve some of the problems using this Mason's gain formula so that we can clearly understand the topic. The problem is about to determine the transfer function of the signal for the shown figure. The figure describes the input is R and output is C, and between that 4 nodes are present from the input to output, representing x1, x2, x3 and x4 respectively, and the forward pass. The first step is to determine the forward pass. So to determine the forward pass, we have in this example we have two forward paths, that is means the forward path is only traversing once and no node is repeated, so that the forward paths here are R, x1, x2, x3, x4 and C, where C is the output node. So here the forward path is R, x1, x2, x3, x4, C, and the second for path is R, x1, x4 and C. So here the x1 to x4 has the gain of g4, which is in similar direction, forward direction, and when comes to x3 to x2, which has the gain of h1, here it is it is not in the forward direction, it is in the backward direction, so it is called a loop. So where P1 is equals to gains of that particular forward path. So for the first forward path we have gains is equals to 1 into G1 into G2 into G3 into 1, that is P1 is equals to G1 G2 G3, and del 1 is equals to 1, and the P2 is equals to, hence it has only x1 to x4, so 1 into g4 into 1, that is equals to P2 is equals to g4. Del 2 is equals to number of loops forming after the removing of the number of loops forming after removing of the particular forward path. So after the removing of the forward path R, x1, x4, C, we have a loop formed, that is G2 H1. So 1 minus G2 H1 is the del 2, and the loops are, here we have only one loop, that is x2, x3 and x2 itself, and it has the gain of G2 H1. So the transfer function is equals to P1 del 1 plus P2 del 2 by del, where del is equals to 1 minus G2 H1. So substituting in this transfer function we get G1 G2 G3 into 1 plus G4 into 1 minus G2 into H1 by 1 minus G2 into H1, so that the transfer function is equals to C by R is equals to G1 G2 G3 plus G4 into 1 minus G2 H1 by 1 minus G2 H1. Let's solve the second problem also. This is also same, that to determine the transfer function for the below shown signal flow graph. Here we have two forward paths. One is R, x1, x2, x3, x4 and C, and the gains for this forward path is G1, G2, G3 into 1, that is equals to G1, G2, G3, and the del 1 is equals to 1. So with removing this forward path we do not have any loops, so that del 1 is equals to 1. When it comes to a second forward path, we have another forward path from R to C, that is R, x1, x4 and C. The gains for this are, between R to x1 we have 1, and between x1 to x4 we have g4, and between x4 to C we have 1. So 1 into g4 into 1, that is equals to P2 is equals to g4, and the del 2 is equals to 1 minus g2 into h1. So after removing this forward path we have a loop, that is x2, x3, x2, that is the gain is G2 H1. So we will take off from that 1 for the particular loop. So 1 minus G2 into H1 is delta 2, and the number of loops in the given signal flow graphs are 2, that is x2, x3, x2. The gain of this x2, x3, x2 are G2 into H1, and the gain of the x3, x4, x3 are G3 into H2, and the total del is equals to 1 minus L1 plus L2. that is 1 minus G2H1 plus G3H3. Here these two loops are touching. If they are non-touching, then we add del, then the del formula becomes del is equals to 1 minus L1 plus L2 plus L1 into L2. So here they are touching nodes, so that we have 1 minus L1 plus L2 itself. So the transfer function is P1 del 1 plus P2 del 2 by del. So it becomes G1 G2 G3 into 1 plus G4 into 1 minus G2 H1 by 1 minus G2 H1 minus G3 H2. Conclusion. When it comes to conclusion, the masses game formula, which is shortly known as MGF, is a method of finding the transfer function of a linear signal flow graph. The formula was derived by Samuel Jefferson Mason, whom it is named after. Mason's game formula is an alternate method to finding the transfer function algebraically by labeling each signal, writing down the equation for how the signal depends on the other signal, and then solving the multiple equations for the output signal in the terms of input signal. Mason's game formula provides a step-by-step method to obtain the transfer function from the signal flow graph. Often, Mason's game formula can be determined by inspection of the signal flow graph. The method can be easily handle signal flow graphs with many variables and loops, including loops with inner loops. Thank you.